This is the second continuation interactive session for class 10 for the subject of physics. And here we were doing chapter 2, work, energy and power, and we have already learned about power in the first video. Now let us study what is energy. The energy of a body is the capacity to do its work. When a body does work, its energy decreases. While if work is done on the body, then its energy increases. So remember it, energy is the ability to do work. And when you do work, suppose I have given you certain work to pick logs of wood from one place and to put on other place. Then what will happen? When you are doing work, your energy decreases gradually. And after some time, you will become tired, isn't it? So here also, when the body do work, then the energy decreases. And if the work is done on the body, then its energy increases. For example, when we run, we lose energy. That is, we are doing work and thus our energy decreases. But while charging a battery, see, you charge your mobile phone. When you are charging, that means you are doing work on the body. And then what happens? The energy increases since the battery is getting charged. So children, energy is also a scalar quantity and its SI and CGS units are same as that of work. That is joule and erg. And 1 joule is equal to 10 raised to power 7 ergs, as it was already discussed in the first lesson of work, power, energy. And children, then we are having many types of energies which you have to learn, and you have to learn all the conversions, especially the conversion given in second point and third point. So first thing is watt hour. What is watt into hour? Children, the formula of energy. First of all, we have already done power. Now, let us study energy. Energy can be written as, it is same as work. So energy, we can say it as power multiplied by time. Power multiplied by time. Now, if I talk about energy in joules, that means SI unit is joules. Then I can say 1 watt multiplied by 1 second. So watt multiplied by second gives you joule, that is SI unit. So 1 watt second is known as joule. But there are many other terms also associated with energy. For example, if I want to find watt hour, this is also unit of energy. See how it is unit of energy? Because power multiplied by time. Power into time is energy. So what is 1 watt hour? Can be written as 1 watt multiplied by 1 hour. Can be written as 1 watt into 3600 seconds. So it becomes 3600 watt multiplied by second. And watt into second is known as, what it is known as? See, I have circled it on the screen. Excellent, children. So 1 watt hour can be written as 3600 joules. What I have done, I have written 1 watt multiplied by 1 hour and I have converted into SI unit such that final answer comes in SI unit. Similarly, there is one more unit, 1 kilowatt hour. This is also known as commercial unit of electrical energy. commercial unit of electrical energy. Electrical energy is usually measured in kilowatt hour, and commercial means which can be actually sold. So 1 kilowatt hour. How to write down? Students, write down as I have written in one watt hour condition. Try to write down how to say 1 kilowatt multiply by 1 hour. Now 1 kilowatt means how many watts? 1000. 1000 means 10 raised to power 3. Okay, let's write down 1000. 1000 watts. Multiply by 3600 seconds. 60 multiplied by 60. How this 3600 coming? You know this thing? In 1 hour you are having 60 minutes and then you are having 60 seconds. So 60 into 60 is 3600. So after this, now write down 36 multiply by 10 raised to power. Children, see how many zeros are there? 5. And then we are left with what? Multiply by second. So 1 kilowatt hour is 36 into 10 raised to power 5. What is watt into seconds? What is this? Can you see it on the screen? Yes, it is joules. So 1 kilowatt hour is equal to 36 into 10 raised to power 5 joules. And if I talk about heat energy, so we have done in our lower classes also, children, that heat energy is measured in, it is not measured in joules, rather we use a special unit for it, calorie. And learn the conversion. 1 calorie is equal to 4.186 joule, which can be easily written as, even you can also learn it as 4.2 joule. So 1 calorie is equal to 4.2 joule. So kindly write down the units, and it is given in the PDF also, and it is given on page number 4 of the PDF sent to you on 24th May. So children, I have written all the units along with the definition. Calorie we will learn in our second last chapter also in detail. For now, kindly learn the conversion. And then we are having one more unit known as electron volt. Children, by now you have learned in chemistry that around the nucleus, electrons revolve in a circular orbit. You have done shells, K shell, L shell, and so on. Now, when this electron is revolving, it is generating some energy. So, the energy transfers in these atomic particles is measured in electron volt. They are measured in electron volt. So, sometimes a question comes that electron volt is unit of which quantity? So you are not just saying energy, you will be saying energy associated with atomic particles. Similarly, if a question comes that whose unit is calorie, don't write down energy. You have to write down heat energy. Be specific. So learn the definitions of these units, and conversions are very important to learn. So now you take a break of 10 minutes again and learn the concept of energy, the units of energy, and the relation between various units with the SI unit of energy. After doing it, we have to start the numericals also. So when you have learned the conversions, then you can open page number 28 to do the numerical. So now open page number 28. Children, in the first question, read the question first of all from your book and then write down the things given to you. Here, force is given 10 kgf. First step, kgf is to be converted to newtons. That means you have to multiply the force, given force, with acceleration due to gravity to find the answer in Newton. And then there are three parts in the question. When the direction of force is same as displacement. Second, when displacement and force are 60 degrees to each other. Thirdly, when displacement is normal to the force. Children, look at the question and then do it yourself. Again, it is given in the PDF also. You can see it in front, but I want you all to try yourself. For doing such questions, you should be knowing the values of cosine. That means cos 0 degree should be known to you. Cos 60 degree should be known to you, and cos 90 also should be known to you. So the numericals of this chapter are very easy. Don't get afraid and try them. And then after doing first question, you may pause this session and try numerical 2, 6, 7, and 8. And then you can resume the questions, the video, for checking your answers also. So children, now you pause the video for around 20 minutes. And in the meantime, do question number, numerical number 1 also, then 2, 6, 7, and 8 in your physics notebook. And then after you are done, you can resume the session further. So first, pause the video. Yes, students, I hope you must have got second question correctly. Mass in the second question is given, height is given, time is also given. So they are saying find the force of gravity. So the force of gravity means you have to find weight of the body. And the formula for weight is, write down yourself, what is the formula of weight? M multiplied by G. Mass into acceleration due to gravity. M into G. Put the value of G, it is given to be taken to 10. So put the value and you get the value of force in newtons. And now write down work done. Work done against the force of gravity. And for its formula should be mg into h. Children, work done by the force of gravity will be weight acting downward, and the height from the ground will be taken as h. So remember this formula, that work done, for gravitational work done, can be written as mg into h also. So you put the values and find the answer of work done. While power is, what do you mean by power? Work upon time. So work you have calculated in second answer, and time is 5 seconds. So again you put the value, that is 3200 divided by 5, and your answer will come in watts. And then coming to question number 6, that you can do yourself. Power is given to you. Find the power in watts. Time is given in hours. Find the answer in seconds. If you want to find energy in kilowatt hour, you will multiply power and time in the unit of kilowatt and hour. And if you want to find the answer in joule, you have to multiply the answer in watts and seconds to get the answer in SI unit. Coming to 7th question, and it is very important question. Very, very important question, students. Kindly have a look. In this question, we are provided that volume of water horizon is 50 liter. First step is, this is volume and it is not mass, children. Volume is given to be 50 liter and height is given to be 25 meter. Time is 5 seconds. So we know that work done can be written as mg into h. G is given to you. Height is given to you. The problem is we are not provided with mass. Many of you write down mass as 50 kg and that is wrong because mass is measured in kilogram. We have been given liter as the unit. First step, let's do the conversion. Children, in 1 liter, there is 10 raised to power minus 3 meter cube. You can directly learn it. In 1 liter, 1 liter means 1 by 1000 of meter cube, that is 10 raised to power minus 3 meter cube. 1 by 1000 can be written as 10 raised to power minus 3. This you have to learn. So children, in 1 liter, this much meter cube, that means 50 liter will be actually equal to 50 multiply by 10 raised to power minus 3 meter cube. This is the volume which we have measured. What is this? I have measured the volume. Still, I need mass. So children, remember mass. The formula of density was mass upon volume. So mass can be written as density multiplied by volume. And in class 9th, first term, we have learned the density of water is 1000 kg per meter cube. So this is 1000 and here it is 50 multiplied by 10 raised to power minus 3. Now this minus 3 and 10 raised to power 3 can cancel out. And we are left with mass as 50 kg. Children, listen. It is not so that every time 50, whatever liter is same amount of kilogram will come. No. If this was 50 liter, this is coming 50 kg only because we are having water. If there was something else, some other liquid, suppose mercury, then your answer would have been 13.6 multiplied by something. So don't directly write down liter into kg. You have to show this entire conversion. That is liter into meter cube and then use the formula of density, mass and volume and find the mass from it. So that is what I have done in the PDF also, and I have bolded it so that you can understand how the things are going on. Once you have calculated mass, then it is easy to find work and power. So the step of finding mass and conversion of volume were the key steps. So I hope this is clear to you. You can go through it again one more time, please. And then do question number 8 yourself. Try this question yourself. Find the work, find the power, find output and input power. There is a term written efficiency. This formula again you have to learn that efficiency is always written as output term upon input term. So output power upon input power. You go through this question carefully, and if you find any doubt in it, we'll discuss it in our class also. So children, with this I come to an end of this session, and you all are requested to do all the questions which are tick marked. So you do question number 3rd, 4th and 5th, and then you do the remaining parts 9, 10th, 11, 12, 13, 14, 15, 16. They are very easy questions and you can do it easily. So with this, I come to an end. Take care, students, and complete the work. Thank you, class.